And thank you for your reply. After analyze your demands and documents you send us, and from here I'm going to show you a video to demonstrate our energy storage system deployed in our factory in Xiamen. Actually, this is the entire inverter room we set up for the whole system. And the battery, for security purpose, we put it into our outdoor use container and deploy it aside of the R&D building, which I will show you later, maybe a picture. And the whole room contains two systems. One is the energy storage system, which right is behind me. Another one is this PV system. It's connected with the PV panels we put on the rooftop of our workshop, and which is mostly regarding generating powers for our daily use. The purpose is actually saving our energy bill. And actually on the screen you can see how our whole system is working. This is the remote monitoring software we were using for the PV system generation monitoring. We also have the software for the energy storage system, but didn't connect it with this computer yet. So I will show you the video about, or the pictures about the monitor software later. And right now let's see how our energy storage system works. The whole control is based on the 7-inch touchscreen on the panel. And from the system you can see the running status of the inverter. You can see the output and input voltage, current, and also the grid frequency, and also total current power we were outputting or inputting because of charging. Sorry. Another thing is the basic charging. From this page you can set the active power and reactive power, and also the working mode, and if you want to enable or disable the low voltage running through function. And also here's the information of the battery, and you can also do the settings on it. And based on our understanding of your system, you are actually requiring two different application requirements. First one is the basic peak shaving system. The other one is the frequency regulation system. And based on our understanding, the peak shaving system, the key function requires in the system is outputting specific power at particular time. So from our system, our system can set at a specific time period doing charging or discharging work. So regarding to your system, which means let's say that you want to do peak shaving from 2 p.m. to 4 p.m. We just need to set discharging time at 2 p.m. to 4 p.m. of the day, and also set the output power at specific range you would like us to do. And besides this, we can also set it with the electricity price for different time periods, and the whole system will do the calculation itself, calculating how the energy was saved and how much you were saving from this charging and discharging process. And for the frequency regulation system, also known as the demand side response system in your documents, what we understand is that the key function required in this system is first, adjustable active and reactive output power. Second, the system needs to tracking the grid frequency. So let's talk about it in two ways. For the static frequency regulation, what we think is that we were taking orders from the control center. It's either you send us or the national grid send to the system, and our unit will respond to specific orders, setting the output status as you required, and which is actually functional right now. What we need to do, just open the communication protocol, reading your orders and do the response. The second one is the dynamic frequency regulation. What we understand for this part is our units needs to tracking the grid frequency and automatically respond to specific frequency reading and outputting particular active and reactive power. As you can see on the screen before, we were actually tracking the grid frequency, and also our active and reactive power is settable. So what we need to do from here is just to create a logic chain connecting both grid frequency reading and specific output status from our system. This part is only involving some software changes, and also we need the specification you send us to create this logic chain. But what I think is that this part is it's easy to achieve. It won't take a long time. And also another thing I want to mention is that for our energy storage system, this touchscreen HMI is not always required. And we also did some systems, we can do the remote communication through RS-485 or TCP/IP protocol. And also just taking the orders from the high-level control software and doing the internal response to it. So we don't need this HMI to setting different kind of charging, discharging time or whatever parameters. Everything is controlled by the high-level control software. And another part is our PV system, which is also one of the biggest business we were focusing right now. And it's using the same kind of touch screen, and you can see the daily generation reading, like put it in the graphic, and also the output power. And from here you will see the daily generation and also yearly generation, monthly and the yearly generation. This system is just set up this year, so there's only 1 year reading. Sorry. And also for running information, you can see the DC side running, which is what's going on in this DC component over here. And also the inverter running status regarding the voltage, current, and also the internal and external temperature, frequency, and also the output power. And for performance, you can set the MPPT disturbing step, active power output, and the power factors. It's pretty much similar with the energy storage, but it's a lot of difference. And also the unit has the total power correction function, which was settable on the touch screen with specific readings you would like the system to be. Okay, that's it.
Hello, James. This is Jim.
This is Emily.
This is our microgrid container system. Later I will show you inside. Actually, this is a demo room. For this one, this is our on-grid inverter. It's a 20 kilowatt inverter. It's a string inverter, and this is our home use energy storage system. We call it SPH. And this two is our home use string inverter, and this one is also SPH. Come here. You can see this is our totally application project of battery energy storage system for microgrid. And you can see this diagram is mainly for the whole system's solution. For example, this PV panel is on roof, like in our workshop, on the top of our workshop, and this is PV inverter. And now here we use the lead carbon battery pack for 800 Ah and 672 volt. The total capacity is 537 kilowatt hour. Our PCS is 500 kilowatt with transformer, so that it can connect to the grid directly. And also we also have some, the diesel generator and some meters and some, control system and the load, and the whole system conclude microgrid system. Come here, I will show you the lead carbon battery inside. For the battery here, we use each one is 2 volt and 800 Ah. So the total capacity is totally one group. The total capacity is, just like I have said, is 537 kilowatt hour. And here our battery system is connected to the microgrid testing room, just like Mr. G has shown you. Okay, for the system, why we use the lead carbon battery? Because this one is a little cheaper than the lithium battery. But for your frequency regulation system, I think it's better to use the lithium battery, because normally the lithium battery is better to use for the a long life, and also for the frequency regulation system. You have to keep the battery SOC. SOC is to make it 50%, so that you can charge and discharge at any time as you want. So this is very important for the system. But for the normal lead acid battery or maybe gel battery, if the SOC is always on 50%, it will make the lifetime totally reduced to a very low level. So I think lithium battery is better for your frequency regulation system. But our lead carbon battery is okay to use in a commercial system, like all the factory system, for peak shaving. So this is our microgrid system. Thank you.
因为这里面这拍几张照片。